Hi, I'm Chris Harduwar. I'm the Vice President of Business Development and Partnerships at MapleSoft. And to me, automation is potential to innovate, to do things better, to do things in a new, faster, smarter way. And it's also a potential to learn and grow, to solve problems and to explore. And to me, automation is exciting, and I'm happy to be part of it.
Welcome to today's episode of This is Automation. Today we have a very special guest with us, Chris Harduwar. How's it going, Chris?
It's going great. Thanks, Corey.
So today we were going to be talking about MapleSoft, MapleSim, and how that's connected with B&R, how to leverage model-based simulation, and lots of really fun things like that. But before we get into that, Chris, can you just tell us a little bit about yourself and your history with MapleSoft and kind of what you do there?
Sure, yeah. I have an engineering background. I've been in the industry for about 20 years, and the industry being engineering and high-tech manufacturing. I've done product development from prototype stage, concept prototype stage, getting customer requirements, and taking that all the way through to production. I've set up global manufacturing in my past as well in Asia for high-tech manufacturing, as well as set up engineering departments in Asia as well. I've done a stint in Germany for an acquisition of a software company. So I have a broad range of experience, I guess, for operations, engineering, and product development in total. Now I'm at MapleSoft, and their primary software and simulation mathematics-based company. So I brought all that knowledge and that background from manufacturing, mechanics and manufacturing, optical as well as electrical systems. I brought that all with me to apply the software to industry that utilizes those environments as well.
So in your role as VP of Business Development, what does that entail? What are you kind of doing on a day-to-day basis, and how are you driving, MapleSoft forward?
Yeah, in this role, really, I'm focused on the strategic partnerships. So working with other large companies who are doing innovative things as well, and really connecting MapleSoft to those types of companies, especially in automation, to create win-win scenarios. And this is more than just where 1 + 1 = 2. It's really where 1 + 1 = 3, 5, 10, and beyond. And we're looking for those, strategic wins and solving customer problems. So a lot of my focus is with automation and bringing MapleSim, one of our products, to the automation space. So I am looking at cool application cases. I'm looking at tough problems. I'm looking at challenges the automation industry is facing, and try to bring that together with a simulation software that can solve some of those problems.
Let's challenge your technical expertise. So let's start kind of with the basics. And can you just explain what a model is when you're talking about these models?
Yeah, a model really is, it's a three-dimensional representation of something. It could be a person, it could be a machine, or it could be an entire system. Sometimes a lot of people are used to models as being a physical prototype, where a smaller, scaled-down version of your thing that you're actually trying to create is built right in front of you. You can touch it, feel it, hold it, play with it. So that's one type of model. The models here at MapleSoft are really based inside of a computer. So these are 3D representations inside the computer that you can play with it as well.
Awesome. So then can you talk about the other side of the equation, which is simulation? So can you just give me a description of like what simulation is?
Yeah, for sure. Simulation really is the production of that model. So it's taking that model in a 3D space, so let's say in your computer, and making it come alive and making it interact with the environment, a simulated environment, and how that model performs. Your hope is that that's how that model will perform in real life once it's physically built. I'll break into like a little bit of an example. I enjoy space exploration and discovery out there, stars and galaxies and things like that. So based on mathematics, Einstein predicted the existence of black holes, and that prediction was basically all on paper, math equations. And then it was only later on that actual black holes were discovered out there in space. Using simulation tools that the aerospace industry and space exploration are using, they simulated galaxies. And when they simulated galaxies, they found that the stars were all flying apart. So they tried to keep the galaxies together, and no matter what they did, the stars were all flying apart. Somehow what we observe in space doesn't really match up with what was shown in the simulation. It was not only until they added a black hole in the center of the galaxy that they found that the galaxy stayed together. And it was only through observation years later that they found that most of all galaxies have supermassive black holes inside. So the power of simulation really showed what was happening in reality. And that's kind of like for me, an exciting way to explain what simulation is. But we've applied that type of simulation where you're trying to predict reality to machines and to robotics. And that's kind of what simulation is to me.
So when I look at MapleSim, some of a phrase that I see a lot is model-based simulation. So is that kind of what you just described, or is that different in any way?
Yeah, our models are based on mathematics at its core, and we turn that into a visual representation. And the link between the mathematics and the visual representation are the physical CAD dimensions, the visualization of the model. So you're actually using multi-domain models to visualize. So it's an easier way to simulate. It's not just equations and numbers that you're getting out of your simulation. You're actually seeing the model animate, perform, and interact with its environment. So that's the model-based simulation.
I'm sure you could talk more about simulation and modeling in general, but probably good enough to just give everybody kind of a baseline for some of the things that you guys are getting yourselves into. So can you talk a little bit about MapleSoft specifically, and then MapleSim, which is a tool that you guys have developed?
Yeah, MapleSoft started over 30 years ago out of the University of Waterloo here in Canada. They, out of the students there and the research projects there, they created software to solve complex equations, and you could actually put the equations in symbolic form, and the software will compute the answer very quickly. From there, MapleSoft grew as a company at large and expanded, bringing this mathematics software to the academic areas where universities and colleges, technical universities would also use the MapleSim math solver to solve big problems. So from there, based on all that knowledge, we created MapleSim several years ago, where it would use the math engine as its backbone and allow you to create simulations of physical products, physical machines, physical anything actually, and reproduce it in a very fast way, close to real time, if not real time itself. So that's where MapleSim came along. And MapleSim really is a product that breaks out of the academic world and goes into the professional and industrial world, solving real problems with the math engine in its back pocket, so to speak.
Good. So where would someone see MapleSim being used today, or maybe just some common applications of MapleSim?
MapleSim really got large success in aerospace and automotive. I'll give you a couple of examples as well. In electric vehicles, MapleSim are used for the battery performance and the whole vehicle itself, from the steering wheels to the tires to the mechanical systems that connect these things. Robotics and automation, it's used there. And most recently, I took a visit to a company where they were using MapleSim to stabilize tall buildings. So the tallest buildings in the world that are being built today require mass dampening systems usually at the top of the building to protect the building from falling over in high wind conditions. All that is simulated in MapleSim before the building's even built. So those are some of the areas right now that it's being used.
So another thing that I saw on the MapleSoft website when I was doing a little bit of research, and I think that other people may come across this, is a reference to Metallica. So can you talk about what Metallica is and how it's integrated with MapleSim?
Yeah, sure. Metallica is an open standard modeling language. It's really the combination of Metallica being an open object-oriented system-level modeling language, with MapleSim, which is a symbolic computational powerhouse, enables a lot of functionality. Takes away the black box of doing design. So it's really an open standard that makes it easier to model because that open standard has predefined models already with it, and it just allows you to create models that are more common.
Another thing that just trying to get through some terminology here is I've seen functional MockUp units. Can you talk just a little bit about those and what they're used for?
Yeah, functional MockUp units, FMUs, are part of the FMI standard, which is functional MockUp interface, and this is an open standard for model exchange, and it's over 40 different organizations are using it now. It's similar to the S function that some of your listeners may be familiar with, but it's really an open way of sharing model from one software tool to another software tool so that your model gets reused and you don't have to recreate something in a different tool.
Mm-hmm. It sounds like a lot of this with Metallica and the FMU integration is really enabling MapleSim to be used in a more open way and maybe help make migration to it a little bit easier.
You got it. Yeah, exactly right.
Another thing that I wanted to talk about, so for someone that's maybe not super familiar with simulation, hasn't done simulation before, another thing they may come across is hardware-in-the-loop simulation. Can you just talk quickly about what hardware-in-the-loop means and then how people would use it?
Yeah, hardware-in-the-loop really, in the context of automation, it really allows you to test your hardware, which are the controllers, against your virtual model. So against your simulated model, the model that's produced is realistic and is able to run in real time from MapleSim. And you can connect that virtual model to the actual hardware to test control code to see how the hardware behaves under different conditions while connected to the virtual model.
Very good. So this is a pretty powerful way to enable simulation, I guess, in automation equipment for sure. I've definitely seen it used there. So yeah, that's a really powerful implementation, I think.
Yeah, it is, and hardware-in-the-loop is new, and being able to add that to your workflow, I think, really unlocks potential for reducing risk and adding some cost savings to your workflow.
We talked about hardware in the loop being used in automation. So what is your view on how simulation is being used in the industrial automation space? Or if it's not being used in that way, how should people be considering simulation as a tool that they can use in industrial automation?
My view is I really think that simulation is essential. It really allows companies to innovate. It unlocks innovation and allows them to save costs, have more predictable time to market, and really allows you to do virtual prototyping, to do your prototype build ahead of the physical build. So I really think simulation has a strong place in automation, and customers already and people that are using it today have nothing but success and good things to say about the time that's saved and the issues that are discovered on the simulated model versus the physical model.
Yeah, definitely. I know we have, one specific use case that I'm thinking of in the B&R world where we were helping a customer develop a machine with some simulation tools, and they found there was some, physical interactions that weren't going to work that, probably would not have been identified until the machine was commissioned and fully built, which is, sunk investment of, presumably hundreds of thousands of dollars where, when it was identified upfront in the simulation, it was easy enough to just change the model and basically turn it around in a few days, if that, to make that change. Versus when you have that physical prototype built, you're looking at potentially weeks plus lead time for new parts, so on and so forth, and it maybe isn't even going to work once you make that design change.
Exactly, Corey. Yeah, I've heard that too, and that story's been repeated by several different groups out there. It's really powerful, and some of the benefits you get from it are outstanding. More than I thought. The amount of cost savings that these companies are telling me are actually more than I thought. So it's good. I'm happy about it that we're able to solve that kind of problem and provide that type of solution.
Yeah, definitely. So there's definitely a few other tools out there. So if someone's interested in taking advantage of simulation for their next machine or, the process in their factory, how does MapleSim differentiate itself from those other tools?
Two main ways I think I can distill it to. One, it's fast, and that's based on the history in mathematics that MapleSoft has. So fast computation power, fast simulations, and allows the controller to really test in real time. And then two, and I hear this from people who've actually used their tool and use other tools out there. It's easy to use. It's easy to get started, and actually our connection with B&R makes that even easier. And I'll get into that a little bit later if you ask me about it, and I'm happy to tell you. But that's the two main areas.
So I guess just to kind of bring us home here on this topic, can you just talk about some of those benefits? We just talked about, cost savings, but what are some of the other benefits that people can expect if they start implementing model-based simulation, as an OEM machine builder or even system integrators we've seen for sure, end users at the manufacturing facility? What are some of those, specific tangible benefits that they may see?
Yeah, so they're able to test functions in the prototype ahead of time before they were able to test before because of the virtual prototype that's created. Do design iterations, so you could really do what-if scenarios. You could update your design on the model itself and see what happens. You could do optimizations. You could see where your motor is maxed out. You could do machine updates. You can make enhancements to your product and see how those enhancements play out. And really, the models can be developed alongside the development process here. You don't have to build something physical before the model can be created, the simulation. You could actually do that ahead of time. So yeah, it helps make decision-making easier. It helps to highlight risks that may pop up on the physical build.
Yeah, and I think a lot of machine builders, at least ones that I work with, are already building out CAD models. So they do have that 3D representation of the machine before they start building. So really, it's kind of a small next step to get to, the model-based simulation to start, testing out the machine design and maybe some of the control loops and things like that.
Yeah, exactly right. Yeah, that 3D CAD is already built, and you don't have to be a mechanical engineer to utilize that CAD. You just import it into your simulation tool, and away you go.
Awesome. So speaking of 3D CAD models, something I've been hearing a lot about is digital twin. So can you just talk about what a digital twin is? I've heard some mixed results.
Yeah, yeah. It's a buzzword, right? So yep, I hear it out there all the time too, and it can mean different things to different use cases, to different people, and to different software tools and different. So a digital twin is really a dynamic virtual representation of a physical thing. And companies out there are actually using digital twins to optimize their products in ways that were previously either unrealistic or impossible to do. A digital twin really with MapleSim is based on real physics and real mathematics of the environment around it, based on the actual CAD information that already exists in your 3D model, and applies that to the dynamics of the real world, and really predicts a realistic outcome for your machine. So that's why we coined it digital twin as well, because the models are so realistic in real life behavior.
Good. So when we talk about digital twin, it's a model of a physical system that exists and maybe is already installed in the field. And this is the digital version of that is kind of the sandbox, maybe is the right word, where you can test things out for optimizations before implementing it on the physical system.
Yeah, exactly right. So, and in your first scenario there where the machine already exists, you could make your digital twin from that, or you can make your digital twin from a concept, from something that's not being built before.
Gotcha.
And the reason why you can do that is because of the physics engine that's involved with the models themselves. You can predict how the machine's going to behave ahead of time and play with it in the sandbox.
Mm-hmm. What kind of problems can a digital twin solve for an engineer, whether that's on the mechanical side or the control side, and then for a company at large as well?
It basically it actually has a wide range of purposes depending on the fidelity that you put into it, but it really serves as a powerful connection to the product for diagnostics and doing design changes. Because it's a physics-based model, you could really put that model to its limits and see how it reacts, and then you can make changes and then see how it reacts again. On the control side, you can actually use this digital twin now to test your control code, and that goes back to your hardware in the loop testing and even software in the loop testing, where the control code that's been developed can run it alongside and run with the digital twin, and you can see the digital twin reacting to the code.
Yeah, I think another place that we've seen it specifically is in training as well, because there's an element of safety if you have new operators working on, heavy equipment, that it can be a potentially dangerous situation. So if you're able to put them into a digital world, for example, with virtual reality or something like that, there's an element of safety there, and they're working within, like you're saying, real physics engines. So the machine's going to behave as if it would, in the physical world. So it's a way to either, train people remotely or just in a safer way, I think.
Yeah, exactly right. Yeah.
Can you talk about the workflow for developing a digital twin?
Sure, I can. Yeah. So it really starts with the CAD. That's the best way to start, but you could start without the CAD too. MapleSim has predefined components that you can start with to play in the palette. You don't, like I said before, you don't have to be a mechanical engineer. You basically bring the CAD in through an import button, and the CAD shows up. You group the components together, and then you drag and drop the connections. So the connections can be a revolute joint, it could be a pusher and actuator. You really connect them up on the palette, and then you could apply a motion to it. So you create a motion in the app that's included in MapleSim, and you could see the machine move, behave, and react to those motions. And you can actually, the visualization outputs the torque and the speed graphs as well, so you have access to all of that. You can actually really see, if you're under designing or over designing certain components of your machine or your motors itself.
Yeah, I think that's really powerful, just to get that design feedback loop working in the digital space instead of the physical space. I've seen many times over where servo motors, for example, are not sized properly, and that doesn't get identified until the actual prototype is on the floor. And like we talked about just a minute ago, if you have to make that change once you already have hardware in hand and a prototype physically built, it's a significant cost and time impact to the project. Whereas when this happens in the digital world with your digital twin, you get, very high fidelity information about how these servos and such should be sized. You get to test that in the digital world. And then when you actually build that physical prototype, you have high level of confidence that it's going to be right the first time.
Oh yeah, I like what you said there. Yeah, you definitely have a high level of confidence that's gonna be right the first time. Yeah, and it's once I find too, like once people start playing with it, start playing with their designs, it really unleashes the potential of what the machine can do, and it really puts
Mhm.
the you can put the boundaries on the machine, or you could like open it wide up and
Right.
add a whole bunch of stuff to do some different things that you didn't think of before, right?
Yeah. Yeah. And I think what you said earlier resonates really well here as well, where, MapleSim and this digital twin simulation is really enabling companies to innovate in a way that they haven't been able to before, just because the design iterations, were so expensive in time and money. You're really kind of limited in how much you can innovate. You kind of just need to get that machine out the door, because I'm sure you've already got orders for it. Whereas now in the digital world, you'll be able to get it to that, first state of stability pretty quickly. And then you can start innovating on that design, like you said, to either take the machine to, its limits, or, optimize it for longevity, or whatever it may be, adding features, so on and so forth. I think it's a really powerful tool.
Yeah, yeah.
Good. So another buzzword that I hear a lot, and I'm sure you hear it too, is virtual commissioning. Can you just kind of break that down, tell the listeners what virtual commissioning really is, and then how some of your customers are implementing it with MapleSim?
Yeah, virtual commissioning really is the act of the commissioning in a virtual space, so on your computer with the simulated model. And virtual commissioning is used broadly out there as well, and a lot of times when we see virtual commissioning in the automation world, it's really about like what I see is mostly is commissioning the whole line. So it's you're adding your products that the machine is actually packaging or pushing through or transporting, and seeing how those products interact with the whole line. That's not where MapleSim sits. So MapleSim sits where the machine is itself. So that's commissioning the machine for the first time, how that machine is going to behave, how that machine is going to perform, what are the limits, and actually putting that virtual machine, connecting it to the control code. So now you're testing your control code with the virtual machine, and that's where the virtual commissioning comes into play. So you're trying to identify some commissioning problems or hiccups ahead of time, because you do have the simulated model. Because I think we all know some of the headaches and some of the issues that do come up with the commissioning phase.
Mm-hmm.
So with this, it gives you an opportunity to discover problems sooner.
Yeah, I think anybody out there that has commissioned a machine knows exactly what you're talking about when you say those hiccups and headaches. It's never as much as you expect it to be, and it always takes longer, and there's always issues. Yeah, if there's a way to mitigate some of those impacts, I think that's really significant. Do you need because you're talking about commissioning a machine virtually, do you need a full digital twin to do that?
Yeah, so to commission the machine, you could have the full digital twin running against the control code, or you could have a portion of it, the most critical part or the new area of the design. You could test partially or fully. So a digital twin, quote unquote, is needed. Depending on the level of fidelity that you want. You can say it's a partial digital twin or a full digital twin. It's really your simulated model that you want to test out. You can test a portion of it, or you can test the whole thing.
Gotcha. Awesome. So can you just talk a little bit more about some of the ways, maybe if you have a specific example, where you've seen virtual commissioning bringing value to a machine builder or a manufacturing facility?
Yeah, for sure. We've had a customer actually tell us about their experience where the control code, something was missing in control code, and the arm swing of the robotic portion of the machine went completely the other way and caused a lot of damage. They basically they based that experience on why they chose to do simulated machines. So that alone, the cost savings on that alone, just to see how your initial code, to see how things behave, because sometimes there could be some wild unknowns there. Also, it helps on machine updates. So you have an existing machine and you want to make some feature enhancements, even speed improvements. Can we turn this thing up faster? So we've seen that benefit the OEM and the machine builder as well. And then like the what if scenarios. What if I change something here? What if I make an optimization there? Like, what happens? How can I play with that without really going to the physical machine and testing it out, causing downtime? We've seen a lot of use cases where they're just testing out these scenarios without affecting the actual machine itself.
Yeah, it's a really powerful story. I haven't heard something like that before, where a minor problem in the control code that easily could have been found in simulation causes some physical damage, and potentially there's a safety risk there as well, right? So
exactly, yeah.
Awesome. So we talked about virtual commissioning and digital twin, the other things that MapleSim enables. I'm sure a lot of people are thinking to themselves right now, like, yeah, but this takes a lot of time and it's complicated. Can you just kind of walk through what is the workload for developing a simulation or model-based simulation like this? And then, what kind of person is capable of doing this? What kind of training do you need, so on and so forth?
Yeah, no problem. Yeah, so the workload is as much as you want to put into it. And what we've seen and what's helpful is that you start small. You start with a portion of the machine. You start in a simplistic way. You get familiar with how the software you'll use, how the software is used, and how that relates to what you see in the real world. So you can have some simple models where you put some components together. And hit simulate. It's really you can have a digital twin created in an hour, or you can have a digital twin created in 2 weeks, depending on the complexity and how much you choose to take on. So we find more often than not that people, once they start using it, they say it's easy to use, it's easy to grasp. If I'm a logical thinker, that's basically all that I need in order to build a simulation. Drag and drop components. Connect them in such a way, and then the beauty of it, you hit simulate and you hit play, you could actually see what happens when you do put things together, and based on that feedback of the visualization, you could make updates and learn from there. You don't have to have a mechanical engineering degree. You don't have to have an electrical degree. It's basically a palette and a sandbox to play in. Once you do understand the logic, you can go forward from there.
Awesome. Well, it sounds like there's no reason not to use simulation.
That's what I say. I say that all the time. That I find, Corey, that the hard part is that people just don't know, right? Like, yeah. You think it could be complicated. I don't want to learn a new tool, right? But once you start playing with it, you really see the power of it, and you realize, hey, this is pretty easy.
I don't know about you. I'm super excited about simulation. I think so excited that we need to take a quick break. And then when we come back, we'll talk about the partnership between B&R and MapleSoft, and then a little bit about the future, what it holds for model-based simulation.
Sounds good, Corey.
Welcome back, everyone. So, Chris, I would like to just take a quick minute and talk about the partnership between B&R and MapleSoft. So can you give us a little background on that partnership and kind of how it got started?
Absolutely. B&R actually started using simulation to solve customer problems based out of their application engineering group in Austria. They're using simulation to, predict machine behavior. So really, their use of it really started the partnership because they liked what they saw, and then they were getting real benefit from it. So we began to talk a little further, and from there, really opened up MapleSim to be connected strongly with B&R software tools, in particular. Automation Studio. So that's how the partnership started. And we became, a lot of people at B&R, we became, strongly connected. We have a lot of good connections over there, a lot of great people, super smart. we've learned a lot from B&R about the industry, about what customers expect, and it's all been exciting. So we were happy to formalize a partnership together, and happy to be out there at the trade shows and be out there in front of customer applications where hardware and software really come together to solve a particular problem.
We're just as excited about the partnership, and we're excited to continue leveraging that relationship. Can you just talk a little bit about what does that partnership mean? There's actually some tangible things that happen where it's really simple to integrate B&R MapleSim, right?
Yeah, that's right. And it really starts with B&R's approach to customers. Yeah, B&R is not selling hardware; they're selling solutions. They're solving a problem, and they're building a long-term relationship, right? And that's exactly where MapleSoft plays as well, and that's where MapleSoft sees value in this partnership. So some of the tangible things that came out of it was the MapleSim and B&R connector. So strong connection on the technical side, where the software allows for a seamless workflow from one software, MapleSim, to the other software, Automation Studio.
Can you just talk about what does that connection look like, and kind of how, I guess maybe from a workflow perspective, how does the B&R MapleSim connector enable a simpler connection?
Yeah, for sure. So that work that started all the way in the CAD from the mechanical team got imported into MapleSim, and then you created your digital twin, you created your model. That work doesn't go to waste. So we created an export function that Automation Studio likes. Automation Studio takes in very simply. So you create your visualization on model, and we send the model and the CAD over to Automation Studio. So now in Automation Studio, when you open it up, you click a few buttons and you import the model.
Awesome. So it sounds super easy.
Yeah, it's pretty easy. And based on the partnership, based on our use of the software, we custom tuned it, right? We have software developers here that we're tuning it for Automation Studio and tuning it for the application. So it's custom tuned for that.
Yeah. I think one of the powerful things with the MapleSim connector is, like you said, the CAD comes over into Automation Studio, and we've got our visualization tool, Scene Viewer, that's well integrated with Automation Studio, so that you can take that MapleSim model and basically visualize it in Automation Studio, directly connected to the machine code running in simulation. So it's a really powerful connector, I think, that brings it's much more than just automatic code generation, I think.
Oh yeah, absolutely right. And we've heard a lot of positive feedback from when we did say, like, okay, you actually get your CAD information. You could see the machine running against your control code in Scene Viewer, and it was a really good response, because a lot of times I think that ease of viewing your machine functioning wasn't there before in the past, or wasn't as easy to get to.
Mm-hmm. So what are some of the use cases that you've seen with the B&R MapleSim connector?
Well, we wanted to keep it simple, right? So if we opened up, there's a lot of parameters that can be opened up, but in order to streamline the workflow, in order to make it really easy for that connection from one tool to the other tool, and that connection's based on that FMU standard we talked about earlier. Mm-hmm. We really locked it down to have only a few parameters, so you move from one tool to the next, and so the use case is basically that. So you can take any level of model, it gets the code for that model gets compressed using the math engine in Maple, so it's very fast code, and then that gets wrapped up with the FMU, and then that gets sent over to Automation Studio in that couple of clicks within MapleSim.
Can you talk about maybe an example of a use case where someone would want to use this? Is this something that is a good fit for every machine, or are there specific types of problems that this is really good at solving?
I think it's applicable to any machine, anywhere where you want to see how your control code behaves ahead of time before it actually gets physically connected to the physical machine. Mm-hmm. I think it's good, and like it could test a small portion of the machine or the full machine itself. So on the broad perspective, I think it's useful in most all cases, especially if you're doing something new. So if it's something that you haven't done before, or something where you're pushing the limits of what your design is capable of, you want to see how it performs virtually ahead of time. So that would be the most use case for that.
So can you talk about how that use case brings value to the machine builder, system integrator, or end user, specifically in the industrial automation space, of course?
Yeah. It and then back again to the virtual commissioning, hardware in the loop testing. It really allows you to see where the potential issues are. It allows you to have confidence, like you said earlier, have confidence in your design, have confidence in your control code. The other areas too, like you can actually show this off. Like you could run the model against the code, and then you have your simulated digital twin here. You could show it to customers, you could show it to management staff, you could show it to other parts of your organization, just to show the how that machine is performing, and then do design tweaks as needed, make updates on the fly and really quick.
Yeah, I think that showing it off is a powerful use case. It's kind of, it's not as nitty gritty engineering as the other stuff where you're doing, very high fidelity simulations and design and so on and so forth. But it is a really powerful visualization tool as well to show, like you said, potential customers. If there's a new machine being developed, you can, start selling that machine, start showing it to your customers, get feedback, so on and so forth before you have that physical machine built. Yeah.
Yeah, exactly. And we've heard cases where what happens if we turn it up by 5%? What happens if we change this little area right here? And you could change that pretty much on the fly, and then you could visualize and see how that see how it moves. The other thing I want to say is that we have a report function as well. So speaking of reporting, like showing it off to other parts of the organization, you could generate a report. And you could see the graphs, you could see the torques on the motors, you could see the visualization, snapshots. We made an app that quickly generates a report for you as well.
So I don't know how it could get much better, but how do you see the role of simulation in the industrial automation space changing in the coming years?
Okay, so before we get to that question, I wanted to mention something else. Is that okay?
Sure. Yeah, go for it. This is your
one of the things what's that?
I said this is your podcast.
one of the other things, and goes along with the partnership and us working with BNR really closely. It's ServoSoft, which allows you. ServoSoft lets you choose your motors, but we have put into MapleSim the ability to connect to ServoSoft directly. So not only do you get your digital twin, you get your file for ServoSoft, which will allow you to select the right size motor, make sure your motor's not oversized or undersized, because that motor is been selected with the full dynamic range of the machine's performance. So that ServoSoft connection, I think, is an important one, and I just wanted to highlight that feature as well.
No, definitely. And I think people that have been using BNR for a long time are kind of familiar with that workflow. When you're sizing a servo machine, we always use ServoSoft, and then when you want to visualize the machine, we always use SceneViewer. And I think the addition of the MapleSim connector to that workflow just makes all of those things that you're kind of already doing in a much more manual way. It makes it way, way easier. So it, I think, really complements kind of our standard workflow for machine design really, really well.
Yeah, you got it. Exactly right.
All right. So back to the other question. How do you see the role of simulation changing in the future?
The role of simulation for industrial automation changing in the coming years, I mean, it really, really allows for innovations. You really now, whereas not before, now you could do some fast tweaks, you could do some fast changes, you could push the machine further as technologies improve, computational power improves, controllers improve. The software definitely is there to keep pace with that, and sometimes, in a lot of cases, because it's based on a computer, outperform that in terms of speed. So your ability do things and put design changes in place to really solve problems, or maybe even create new opportunities with your product, with your machine, it really exists now. And flexibility, I mean, talk about product changeovers on a manufacturing line, right? Like just the customization of products out there, from having your name on Coca-Cola bottles and changing the line over really fast. I think what simulation allows, it allows you to develop machines, develop mechanisms, and develop systems that can really adapt and change quickly. And then, going forward, combine that with artificial intelligence, down the road, combine that with advancements, and even with 5G coming, combine that with other technologies, you really have your digital twin, providing more value while it's created, and providing more value after it's created as well, to use that data to really improve your process, and to really improve improve the situation you're trying to overcome, really develop better, innovate faster, and create new cool things.
Definitely, very well said. And I think specifically in the fields of, machine learning and artificial intelligence, like you mentioned, it's something that, more and more people in the industry are starting to get engaged with, just because of, how far it's come from, the start of that, segment back in whatever, the 80s or something like that. It's come quite a long way, and it's starting to finally be viable, like you said, with faster processors and, more computational power. And as that continues into the future, I think simulation is going to be a really, really important part of implementing, AI and machine learning agents into machines and into industrial automation in general, because it basically enables you to have this very tightly controlled environment that you can run at accelerated times. And so you can teach these machine learning agents very quickly, and basically, kind of what we're doing now with developing prototypes, but just developing machine learning algorithms in the future. You kind of need a simulation to do that.
Yeah, absolutely right. Well said, Corey. I think with and the way that that MapleSim is connected with Automation Studio, it gives you a familiar an easy way to start. And now, if you do have simulation in your workflows, in your environment, in the hands of your staff as well, like you're well equipped for the future. You're equipped to take advantage of some of that machine learning that's coming down the pipeline, right? If you have an easy way to start, as software evolves, as hardware evolves, as computational power evolves, you have the backbone there to progress along with those technologies as well.
What can we expect from the partnership between B&R and MapleSoft in the future? Is there anything in the works that you can share?
There's quite a few exciting things in the works. Some of them I can't share on the public podcast, but we're excited. B&R is excited. One thing that you'll see is some deeper integration. So we're well connected right now, but like from a software perspective, from a visualization perspective, you'll see that even more fluid. You'll see that even more feature rich, and you'll see that more even easier to use. That's one. And the other thing I'm super excited about is ActiPost Track. So we've done a lot of work with ActiPost Track. I think that track technology is absolutely amazing. Just the speed of the track, the direction changes, the intelligence in the track itself. I think it's really exciting, and we're starting to combine that now with new ways of using our MapleSim simulations, and it's really producing some really cool stuff. So you'll see more of that coming out too.
Any closing remarks for the listeners about simulation, MapleSim, anything?
Really, just the partnership with B&R has been great. It's allowed us to unlock further developments for the automation industry with simulation. We've learned a lot, like I said, from B&R, and we hope to see that progress. It's a bright future ahead as industrial automation progresses towards further down Industry 4.0 and connected devices, connected machines. I think there's a lot of potential. Like I said at the beginning, what does automation mean to me? It's potential to innovate, potential to do things better, potential to solve problems and really connect solutions and connect your own mindset to what problems are there out there to solve and move forward with that.
Awesome. Well, this was a really fun conversation. I know that the listeners got a lot of value out of this. If anybody wants to get in touch with you or someone on the MapleSoft team to ask questions or just learn more about MapleSoft and MapleSim, is there a good way for them to do that?
Yeah, you could reach me directly at my email address, which is charduwar@maplesoft.com. That's CHARDUWAR at maplesoft.com. You can check out our website at maplesoft.com as well. And we'll be soon launching a subsidiary website called virtualcommissioning.com as well. And you'll see some cool thought leadership stuff on that side as well.
Well, thank you so much, Chris, for joining for the conversation. Like I said, I really enjoyed it. I think this was a really good topic to cover, and I think a lot of people are going to really enjoy this one.
Thanks a lot, Corey. And I wanted to say I think you're doing great things with this podcast. There isn't really a podcast like this out there today. Some of the guests that you have on your podcast and some of the topics that you cover really it's a fun and easy way to get to know automation and to also get to know some of the cool technologies that are out there. So I think this is great. I'm a subscriber, so I hope and I know it's going to go in great places with this. So good work on that.
Thanks, Chris. That means a lot. I appreciate it. In future episodes, we're going to be diving into more topics and common questions in automation. We've got really exciting episodes lined up on IIoT, everyone's favorite topic, safety, servos, machine vision, lots more. We have a lot more special guests lined up and special topics that you definitely want to keep an eye out for. So make sure that you subscribe to the podcast on Apple Podcasts, Spotify, or wherever you listen to podcasts. And if you enjoyed it, please let us know by leaving a review or comment. And if you want to get in touch with me or have an idea for the show, you can pass that along to me on LinkedIn or by email at automationpodcast@gmail.com. In between episodes, make sure you take some time to check out not only the MapleSoft website, but also the B&R website, br-automation.com, and the YouTube channel. You can just search B&R Automation in YouTube to find that. There's a great video on the MapleSim connector, some tutorials as well on that if you wanted to see more information, and everything else that B&R has to offer. Thank you so much for listening, and we'll see you next time on This is Automation.